All right, cool guys. So we have a cool workshop today. So it's Coreum and Anchain workshop. So I have Freddie with me from the Anchain team. Freddie, if you would just like to give a quick intro about you, about Anchain, and how was your experience working with Coreum, man? Just if you can.
Yeah, definitely. Hello, everybody. Um, as uh, as Jay just said, I'm Freddie from Anchain. I lead global BD here for the public and private sector. Been with the firm for about 2 years or so. Prior to this, had a small stint on the Coinbase wallet team, so definitely have experience in the space here. Yeah, working with the Coreum team has been great. I believe we connected with you guys while on a trip in Europe. Great conversation, which led to this great relationship so far. And one thing I will attest to is that you guys are very open and very open to conversations and a lot of insights going back and forth. Conversations have been great. So definitely appreciate everything you guys are doing for Web3 and the ecosystem, and we're glad to be aboard.
Awesome, man. Good to hear. So, yeah, guys. So today's workshop will be around risk scores. So Anchain has actually integrated with us actually 3 weeks ago. So they have completed every milestone. So today I will show you how it looks like. I have created a full stack application. Gonna show you the back end. Gonna show you the front end, and I will just explain you every single thing how the Enchain API works. If you guys want to go ahead, I will also send you guys the link. You guys can create the API, can interact with the API, and yeah. So yeah, Freddie, if you want to stay here, obviously it's up to you, man. And
Yeah, I can definitely hang out, and I realize I totally botched the Anchain overview there. But just to give you guys a little bit more information, just like Jay was saying, we're a risk analysis and blockchain intelligence firm. We do anything from investigations to tagging AML data on these different ecosystems. We've worked with about 20 ecosystems so far. We're U.S. government contracted by a lot of private entities as well. We're leading a lot of the investigations happening on a high scale here in the United States. And again, very excited to be here, very excited to work with the Coreum team. But yes, I'll hang out. I'll hang out.
awesome, man. All right, guys, let me share my screen real quick. So all right, let me know if you guys can see my screen. I think you guys should. All right. So is Freddy? Is my screen visible? All right. Okay. It seems like it's visible.
Looks
Cool.
good.
All right. Cool. All right, guys. So today's goal is, as Freddie mentioned, it's all about security and it's all about collaboration with Engine. So just to give you quick context, Uh, so as Freddie mentioned that they actually have integrated Coreum. I will send you some documentation as well. If you guys want to go ahead and look at their documentation, understand how their API works. But here I will just give you a little bit quick context about the APIs, about the machine learning stuff, how you can how you can work with these kind of APIs. So let's dive into the presentation here. So risk score. Today's goal is to understand about risk scores. So I will be basically using Anchain API, and I'm gonna be calling their API to detect the risk score of Coreum address. So the goal is to understand, guys, when you are working with risk score is basically obviously detecting any kind of malicious transactions that the address is doing, right? So now obviously uh, so it is around kind of like a machine learning and AI that Engine is doing. So to build any model, to build any good model, the very first step is to have you have to collect data. So right now, for example, if you want to create your own model that predicts something or that detects any kind of malicious transactions on blockchain, you always should have data, right? Because if you don't have any reliable or transparent data, you won't be able to make a good model. Um, so right here, we're going to talk about on-chain data. So you can gather transaction history. You can gather token balances, smart contract interactions, governance participation for each Coreum address. So this data can be fetched using Coreum's node addresses or APIs. Nothing but just acquiring the blockchain itself using appropriate tools. I will show you guys how it works. So no worries on that. And so the first step, as I mentioned, it's data collection. The second step is to do feature engineering. So feature engineering, what it means is, so we have input features and we have output features. Not features, but output, basically predicting whether this address is malicious or not, right? Giving a binary classification. For example, one is we can think one is okay. If this address is malicious, zero means okay, this address is not malicious. So here we're going to talk about feature engineering. We can have different transaction patterns. We can have features that based on transaction frequency, volumes, counterparties, and addresses that have many transactions with known malicious wallets might have a higher risk. Obviously, if there's any address that have many transactions, it could be a possibility. There's a probability that okay, if that address has so many transactions, could be they could be engaging. They might be engaging with malicious wallets. For example, I myself have been. I have been scammed, or I have been also been rugged, been scammed by different providers. But I don't want to say no names, but here. But anyways, so yeah, I guess this is really important to understand transaction patterns, and then obviously token holding behavior. Analyze type of tokens held by the address, what kind of tokens they're holding. Obviously, it could include Coreum tokens, or it could include any kind of fungible or non-fungible tokens on Coreum. And then you can also try to understand the contract interactions, identify the number of interactions with high risk or unverified smart contracts. That if that address is actually interacting with any smart contract, or if it's calling any kind of functions, any kind of things. So these are the features. We have more features, obviously. Governance participation, so track the involvement of address. Government proposals, if they vote for any malicious proposals, or if they're manipulating anything. We can also detect these kind of things. We have something called anomaly detection in machine learning. So in machine learning, if you guys understand a concept of normal distribution, I, I I hopefully you guys understand this concept. We have a concept this in machine in high schools. So basically, normal distribution. You can think, okay, we have different ranges. So we have 95% ranges. That's where your data lies usually. If your data lies uh, if your data doesn't lie in 95% range, or if it's lying in 2.5 range, that means these data, we can consider them as is outliers. So it's unusual to have these kind of data. So we can, if you want to understand more about anomaly detection, I would just say go ahead, understand about z-scores, go understand about standard deviation, understand about mean, median, mode, and hopefully you can understand about these concepts. So that's the concept for anomaly detection. Really important in blockchain if you want to understand how you can flag unusual transaction patterns, how you can see large transfers, or any kind of like money laundering or fraud. You guys can definitely see with these anomaly detections. As I mentioned, understand the concept of normal distributions, understand the concept of probability, stats. You need to understand these concepts, guys, if you want to understand how the machine learning works. Really important concepts for machine learning. And yeah, so for risk score calculation, we have different machine learning techniques. We have something called supervised learning, and we have something called unsupervised learning. So supervised learning, you can think of as that we have label data, we have input and a label attached to it. So Supervised learning, in supervised learning, you can predict something with input features and labels. Okay, so labeling, can you can think of, okay, we have historical data that can be labeled as high risk or low risk based on incidents. So we can label it. Okay, this this transaction was malicious. Okay, this address has been involved in scams or malicious activities. So we can just label that input or that feature or that address, just labeling them as high risk or low risk, depends on the incidents. And then we have different classification models using logistic regressions. These are basically, I wouldn't say, I mean, I would say basic for a good, I mean, if you know machine learning, if you're an AI engineer, really basic understanding. It's called logistic regressions, basically binary classification, one or zero. And then we have random forests. Before understanding random forests, you should understand decision trees, and then obviously try to understand the optimization techniques like XGBoost. There's many different boosting algorithms to predict the risk score of address. So you would, as mentioned, data collection is important. Then you would need to do feature engineering. Then obviously you will go ahead and do the risk score calculation using the machine learning. So these models are trained on label data to classify whether this address is a high risk or low risk, right? So I don't see this as a really complex. But now, once we have understood the concept of data collection, we have understood the concept of feature engineering, we have understood the concept of risk calculation using machine learning techniques. But because now we have gathered all the information, we have gathered, we did the labeling, we have addresses, we know every kind of stuff with our historical data that we have captured from Coreum, and as I'm gonna show you how you're gonna capture with Coreum by using our node addresses. You can see tons of data. What kind of addresses is there? Their history, their transaction history, their interaction with different contracts, if they hold any kind of tokens. So I'm gonna show you every single thing. No worries about that. Okay. But guys, we have something called metrics. If you wanna build a good model, obviously you should have a metrics. So you should understand whether this model is accurate or not. You need to understand their accuracy, you need to understand their position, recall, and F scores, just to evaluate your model, whether this model is performing good or not. Okay. So yeah, so this is your risk score calculation, and we have something else we call unsupervised learning. So unsupervised learning, in unsupervised learning, we don't have any labeled data. We have unlabeled data. So unlabeled data, you can think of that basically unsupervised learning, you can think of as that we don't have unlabeled data, first of all, right? And then understanding, okay, that these unsupervised learning are used for anomaly detection, for clustering. Clustering means giving different segments, or l- giving or labeling the different segments or different groups into different segments. So that's what unsupervised learning is. uh, Obviously, once everything is done, then you have to deploy your model somewhere. You can deploy it on depends on where you want to deploy it, right? If you want to deploy it on AWS, if you want to deploy on Google, or depends on you guys, right? So as I understand, I mean, so that's how the risk score works. Hopefully you guys understand a little bit concept, but obviously I can go more in depth because it's I want to show you the code, how the code works. And then um yeah, I guess let's see if there's any questions, because obviously I'm just throwing a lot of information here, guys. If you have any concerns or questions, let me know. Let me go to the chat, understand. uh, okay, let me know, guys, if you have any questions. Please ask me. So this today is a lot about. Um, it's really new concept for you guys, so it's better for you guys to ask as many questions to me. That would be really cool. I'll just give a minute or two. I'll just in that case, I will just drink some water. You know what I mean? All right, cool. I don't see any questions, guys. As mentioned, if you have any concerns or questions, please let me know. Okay, I don't see any questions, guys. All right, cool. Then let's hop back to the presentation. Now let's actually hop back to the code. I want to show you the code, guys. It's important. The code. Hopefully, you guys will like it. So let me share my other screen, you guys. Sorry, just give me a second here. I'm gonna share my other screen. Mm, sorry, guys. Let me go to my VS Code. All right, cool, 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 cool. All right, cool, guys. Can you see my? Can you guys see my screen? Hmm? Let me know. Just give me a thumbs up in the chat so I can understand. Okay, that you guys are able to see my screen. Now, so if you can just that would be cool. Yes, now it looks good. So I can definitely see that you guys can see my screen, which is good. So what I'm gonna do here is I'm just gonna enter the uh, the full screen. Just give me a second here. Enter full screen. All right, cool, guys. So all right, so guys, I'm already running my backend here, and I'm already running the Next.js application. So what I did here is, guys, I have built the Python in Python. My backend is on Python, and my front end is obviously on Next.js. So hopefully you guys understand Python and you guys understand JavaScript or Next.js concepts. I think I have already talked about these things in my previous workshops. If you don't understand these concepts, guys, I would definitely recommend you guys to go back to the previous workshops, understand about the basics. Then I think it's gonna be better for you guys to understand about what I'm just about to do, because I have done multiple. I've explained to you about APIs, how you can interact your backend with your front end. But still, it's okay if you guys don't understand. Today we're talking about Python. Previously, I talked about Golang and Rust, but right now we're just gonna go ahead and explain you about the Python. So let's go to the code. So few concepts. So here, guys, I'm using Fast API. There's no sponsors, nothing like that. Just a recommendation. Fast API is actually really good, really good. I have I've been using this the Fast API. Really easy to use, really powerful to use. If you're a Python developer, I would recommend you guys to understand Fast APIs. In general, understand APIs concept. But here, we're just gonna talk about the uh, the basic stuff. Okay, guys. All right, cool. So here we have different constants here. So we have Coreum node URL. We have Anchain API URL. So this is the Anchain API URL that I'm gonna be using, and then we have Anchain API key that I have this API key, right? And here just nothing but just initializing my Fast API app equals to Fast API. I'm just initializing it here. Here we're just nothing but just allowing course for your front end. So if you guys don't, hopefully you guys understand the concept of middleware. So I'm just giving the localhost to 3000. So what that means is that our front end, or only our front end, can communicate with with this backend. So if, for example, if there is any request coming from local 5173 or local 800 or local 3001, then it won't be giving the response back to these local. Only if my front end, that means my front end is basically localhost 3000, which is obviously I'm running right now. If I do 3001, it's not gonna give the response back to the front end. So hopefully you guys understand about this concept, right? And it's just nothing crazy. But here, obviously, I'm giving course middleware. I'm allowing the origin, which is my local host. As mentioned, only my front end can call this backend. None of the other front ends can call. And then we have a class. So hopefully you guys understand the concept of classes. So we have something in Python, we have class where we are inheriting the base model. So this base model allows us to validate the data. So it allow us to validate the data, modify the data if you want to. That's why we're using base model. It's given by Pydentic. It's a module. It's called Pydentic, and you can just obviously import from there. And then, yeah, that's how you create a class. Right here, we're just using a modern Python. I don't know if you guys know about modern Python. That's how we basically create functions and create stuff like that. But here, we're just checking the address risk. So within this function, we have address, which is called string. And then here, we are returning a dictionary. Okay. So if you can see right here, we have params, we have Coreum, we have address API, which is our Anchain API key, which will be used to call Anchain API. And here, nothing but we're just calling request. So request is a module in Python, which can be used to get the or get or just fetch from the Anchain API URL. And here we're just passing the params, which is these params, right? And then here we're just calling response for status. Here we're just calling response.json. Obviously we need the information in JSON, so we just have to convert back into the JSON format. And obviously this is kind of like dictionary format, right? So in curly braces, so this is like, you can understand this is JSON format. Okay. And then later on, we are doing nothing here. We're just extracting the relevant risk information. So we have address valid, we have risk score, we have risk level, we have verdict time, categories, and details. So we're just nothing but we're just getting this information. Okay. And here we're just returning, again, we are returning this kind of like returning back in the dictionary format, right? And here, if you're in JavaScript, if you understand JavaScript, then I guess it's, you can call this object, right? So we're returning object, but in Python we call it dictionary, and that's what we're doing here. So here, to use the APIs or to create an API, we have to call at app.post. Here we're just creating a risk score, and here we're just calling response model equals a dictionary. Okay, so we're creating a function. Now, whenever I'm gonna call this function, guys, this API will trigger, which is called risk score. And now you're gonna be just wondering, what is this app.post? App.post, nothing but right here, we're using app by fast API, and I'm just doing at app.post. So there's different methods, right? We have get, post, put, delete. Post is to create a new resource. Put is just to update the existing resource, and get is just to fetch the information from that particular API. That's what we're doing here, guys, right? We're posting the information, or we're just creating a new resource, which is to get risk score, which is easy. Remember, last few workshops, I told you guys how to communicate. Whenever you're communicating with database, whenever you're communicating with APIs, you're always going to use try and catch in JS. But here, because we're using Python, we're going to use try and accept. In try, we're just nothing but we're just getting single address from the request, and we're checking and we're applying these functions that we have already created to the addresses, and we're just returning back into the dictionary format because that's what we want. Okay, and here just nothing but creating a this is just to just for testing out purposes. Okay, that fast API indeed is running. Okay, so this is the backend, guys. Hopefully you guys understood this really basic backend that I've created for you guys. Now let's hop back to the Next.js application. So if you guys see in our source folder, we have pages. Within this pages, we have API folder, we have fonts, we have app, we have document, we have index. But what we care only about in this application is about the API and the index. Right now, we don't care about app because app just is here, nothing but just returning the component and the props. Hopefully, you guys understand these concepts, so we don't have to we don't have to dig deep dive into these kind of information, because we only care about the API folder, and we care about the index where the information, or where we could think. I'm going to show you how the index.tss works. Okay, cool. So here we have Axios instance. So we're creating a Axios instance. So if you guys see right here, we have interceptors. Interceptors is really important concept in your Axios. You can think of modifying the request and modifying the response. That's why we use interceptors, just to modify the request, modify the response. It's really handy feature by Axios. I love this feature, but it's not crazy. Uh, it's not really crazy or really crazy concept here, guys. So hopefully you guys understand this concept. Okay, so let's go back uh, to the real code. So here we have interface. I have created this interface because that's how you do in TypeScript. So I've created address valid, we have risk level, we have risk score, we have verdict time, we have categories, and then we have details, right? This is the interface. And then we have a main function here. So within this main function, we have different states. We have address state, we have risk info, we have loading, then we have error, and then we have something called for set for updating these addresses, for updating these risk information, then updating these loading, and then update the error, right? That's what we're doing here for these states. And then here, I think it's a basic, really basic information. So just to let you guys know, I'm here obviously importing the Axios instance from the API folder, and obviously the basic imports. And then here we are creating a risk score function. As mentioned, always use try catch whenever you are playing with Axios, right? So here we are saying to get the risk score, you have to say set loading to true and set error to null, obviously. And then we have a try catch function, try catch finally. Okay, so try within this try, we are posting the information. We're creating a resource for risk score, and obviously we're attaching an address to it, and nothing but here we're just updating our risk info. And if it doesn't work out, if the response is not good, it's gonna just throw us an error, which is gonna say, okay, fetching, there's an error with fetching the risk score. Okay, and here we are just doing basic CSS, guys. Here we're just creating different input. Within this different input, we have a on-chain event, which is triggering the handle input change. So which is this, obviously, right? This is the handle input change, which is whenever we're gonna change the address, we always have to use on change, right? And here we're using class name just to apply CSS to it. Um, so yeah, guys, this is basic, really basic CSS that we have. I want to show you guys how the front end and the back end looks like. So let's go back to the oh man, I'm having a problem here. So okay, so let me go back to the what is it called, my front end, which is the localhost 3000. So I'm gonna share the other screen here, guys. uh, all right, so let me share the localhost 3000. So here is the front end, and obviously as mentioned the backend is already running. So let me actually share the whole screen. So I'm gonna just give me a second, guys, sorry about that. I'm gonna share and just share my entire screen so you guys understand what's going on. All right, cool. So what I'm gonna do is, guys, I already have opened the block explorer. I'm just gonna maximize the screen so you guys don't have any issues. So what we can do is, guys, we can go to the explorer.coreum.validators. So these are the validators, different validators that we have. What I can do is I can just go ahead and just choose the first Zen Lounge. Let's say Zen Lounge, right? We can just go ahead and just, I'm gonna copy the address. Okay, I'm gonna copy this address. Gonna go back. I'm just gonna refresh my local host. Gonna go paste the address here, and now we're gonna check the risk score. Boom. If you guys can see right here that we are indeed getting a risk score. So let me actually show you important thing. Actually, let me tell you this really important thing. So we have different risk levels. So we have risk level 1, which is 0 to 20 or 0 to 30. That's not considered as risky. Risk 2 is basically 50, which is non-risky. After 50, after 60, we do consider a little bit risky that okay, this address might be doing something that we're not aware of. It could be doing some malicious stuff on Coreum. So right now, if you can see right here, Zen Lounge, they are doing good. So their risk score is 50. Their verdict time, and obviously their category and their risk level, so which is awesome. And then we can see different. Yeah, let's grab this address, informal systems, or you can grab anything, guys. You know what I mean. So let's go back right here, and I'm just gonna paste the address. I'm just gonna refresh it so that I don't have any issue, and boom, the risk level is 0, which is obviously there's no risk attached to it. And if you can see right here, details, validator, informal systems, it's also showing this is a validator, so which is cool, right? And then yeah, let's go to transaction. There's different transactions that's happening on Coreum, so we can just copy these addresses and see what's happening. Let's refresh it. I'm just gonna paste this address again to see the risk score. Okay, the details. If you can see right here, the risk level is 2, risk score is 50. This was a random address that I have just grabbed from the Explorer. If you want to go ahead, you can do that as well. So yeah, let's go ahead and do something else. Let's view all the transactions here. So we have bunch of transactions here. Okay, we have this. We have bunch of transactions. So I want to see what address I should get here. So let's take this address just for an example. Here I'm just gonna refresh it, gonna check the risk score, and boom, the risk score is just giving us right. Uh, so just to mention again, so these are Anchain APIs that I'm just calling the Anchain API. Okay, let's just do one more time. And let's make sure we're doing some another address. Let's do this sender address. I'm just grabbing random addresses, guys. It's not okay. I don't even know these addresses. So yeah, I'm just gonna check the risk score. If you guys can see right here, risk score is attached 50. So that means this address is good, not involved any kind of malicious transactions or malicious activities on Coreum. So which is really awesome. So yeah, guys. So that's how the Anchain API works, or Anchain full stack that I have built for you guys. So that's how it works. So one thing, if you guys want to understand, if you guys I'm actually talking to all of you guys, right? If you think okay, if you see any kind of like malicious transactions or malicious addresses that are involved in suspicious activities, go ahead to web3guard.io. So this is the web3.guard.io by Anchain. As you can see right here, go to the web3.guard.io and go to Coreum. When you're gonna click this to the Coreum, you can file a report, right? You can let me just show you how it works. Let me go back. Let me just okay. Sorry. Okay. I'm gonna show you right here, and now you can just file a report. You can just give an address if you think okay, this address, for example, I'm just giving an example. You can just grab random address, not random address, but obviously if you see any kind of addresses that are malicious, go ahead, attach to it. You can just say Coreum, and then you can just give a URL if you have, and then go next, file report, explain the details, and once it's done, you're gonna see, okay, that's then you can go ahead and reports, and then obviously you can call the Anchain API to see whether this transaction or whether this address is involved in any kind of malicious stuff on Coreum, right? So really, really powerful, really cool uh, application, I would say, by Anchain. Love it. So yeah, guys, that's the workshop for today. I don't know if you have any questions or any concerns. Hopefully, you guys enjoyed uh, the workshop. So I have a few questions from. All right, let me just stop sharing my screen. So I see when filing a report with via Web3 Guard Tool, who does the report get submitted to? Yeah, good question. So the report is being submitted to Anchain. So Anchain, they're gonna analyze, they're gonna apply their model, they're gonna apply whatever they have, they're gonna apply it to their address, gonna see the historical data, they will see their data, transaction history, and what they have been doing for whatever the time is, they will just analyze it, and then the report will be ready for you guys to see whether this address has been involved in any kind of stuff. But obviously you have to call Anchain API to see whether this address is flagged as suspicious. So yeah, that's what the Web3 Guard tool is, and then yeah, Freddie. Obviously, we have Freddie as well. Freddie, if you wanna, obviously.
Yeah, definitely. And to be a little more, you hit it right on the money, but to add more specifics there, we have an intelligence team really spread out all over the world, working with, again, private companies, public sector, and they're just around the clock gathering intelligence on scams, on the dark net, open source information that we're gathering from our own investigations. Their job is really to just look for scams, look for fraud, label these different entities, these different wallets, and figure out who's behind them somehow. So once the form is submitted, it does go to our intelligence team. As Jay was saying, it's analyzed, and then we apply the label as such. We don't just apply the label right after you submit the form, because we've seen instances where the information given is not accurate. So yeah, we definitely analyze the data before we implement any labels. Yeah.
Perfect, perfect. Yes.
And then to just add a little bit more there, some of you might be asking why this is majorly important. As you all know, there is really no suspicious activity reports that anyone could submit in the blockchain ecosystem, right? In the banking
Yes.
industry, right? There's the SAR reports people fill out. All banks are in contact with each other, but here it's up to us to kind of self-regulate ourselves, and that's what we're trying to do here. We're trying to give Coreum ecosystem a platform to kind of self-regulate, help each other out, keep each other safe, and that's what we're here to do.
Awesome, man. That's nice. That's actually good to hear. All right, cool. Thank you, Freddie, for being with us here today. Really appreciate you, and Kristen. I understand he's not here today, but yeah, hopefully he feels better. And yeah, hopefully you guys. I don't know if you guys have any questions, guys, but for Freddie or for me, if not, then yeah, I guess I will see you guys in 2 weeks' time.
And if
All right.
anybody has any questions, feel free to reach out. Very nice to meet everybody. Thank you, Jay.
All right. Thank you, Freddie. It was nice meeting you. Thank you, guys. Later.